let's say I had a table of values, and I'm going to kind of write some points on here. Let's say I had this table of value right here, okay? And I want to know, are these points on the same line? Again, this is just something extra that I need to teach you, okay? And then we'll do a problem out of the book. But there's more than just the problem I need to talk about. There's a little bit more to it. Are these points on the same line? Not a problem in the book, just something we're going to talk about. Here's how I can know. Isn't the slope the change in the y's over the change in the x's, right? Okay. So if I look at here's how I can know if they're on the same line. If the slope is the same between any two sets of points, then we would know these are all on the same line. So here's what we're going to do. As I go from 6 to 9, what did I do? Added 3, right? To get from 6 to 9, don't you add 3? To get from 9 to 12, don't you add 3? Okay. This is a good sign that these are the same numbers here. It doesn't necessarily mean. Let me just go. Let's do a simple one, then I'll show you something that can look wrong but be right. Let me go over here. So it looks like my change in y is 3 on both of those. Now let's go to the other side. How do I get from 2 to 0? Subtract 2. How do I get from 0 to negative 2? Subtract 2. So it looks like my change in x is subtract 2. So that would be my slope. These are all on the same line. They have the same slope. Now here's really kind of what if I wanted to be technical, what I really need to look at. The slope between those points is 3 over negative 2. And the slope between these points is 3 over negative 2. Because it's the change in y over the change in x. So I could this is kind of like what we were doing when we were taking the points and putting them in a table and, seeing what the slope is just by doing it in the table. This is kind of the same thing, except sometimes you get more than one set of points. What if I'd had this? And what if I were to do this again? Let's look at this again, because you might think something's wrong here. From 6 to 12, how do I get from 6 to 12? Add 6. How do I get from 2 to minus 2? Actually, subtract 2 would get me to 0, so I need to subtract 2 more, it'd be 4, right? Subtract 4. So between these 2 points, just the 2 that I did, wouldn't it have a slope of 6 over negative 4, because the y's go on top, the x's go on the bottom? But what does that reduce to? 3 over 2, a negative 3 over 2, right? Okay, let's do the next set of points. I'll do them in a different color. From 12 to 15, what do? I add 3, and from negative 2 to negative 4, I subtract 2, right? Minus 2. Okay. So now the slope there would be 3 over minus 2. Are all those points on the same line? No. Do they have the same slope? They do. Do you remember how I got 6 over negative 4, but didn't it reduce to negative 3 halves? And then over here it just actually was negative 3 halves. Some books will only give you some where it's like the first instance where you have the same number on both sides and you know really quickly that it's a line because you got the same number on both sides. But like, for instance, if you were in public school and you took the state test, they mixed the points up like this just to confuse you. It's still the same slope because the fractions reduce. Now, not all of them are always going to be the same. I know these are on the same line because they have the same slope. Okay? So, yes, these are on the same line. They have the same slope. That's what I need to get out of this. Sometimes it's really easy, like the top where all the numbers on each side match up, so you know all the changes in y's are the same and the changes in the x's are the same. But then if they mix the points up, like all I did here was I put them out of order and I added a point. It can look for a minute like it's not going to work out, but if you actually make the fractions and put the y's over the change in y's over the change in the x, they actually do reduce down to the same slope. Let's do one out of your book, though, and see what your book's tendencies are going to be, because they can, sometimes they're going to want to confuse you. Does anybody need to copy something here before I go to the next slide? Okay, use your book for a minute. Like, you go into 35, and so I think that's where we start running into these problems. Yeah. Okay, so I'm going to do 35 because there's 4 points on it, and who knows how that's going to go, right? So let's do this. Let's put them in a table. And it's 0, oh, you can go ahead, I can see the turn. 0, -1, 1, -2, 2, -4, and -1, 0. How am I going to know if these are the same line, on the same line? The slopes have to be equal in between each sets of points, okay? So let's just kind of see what's happening here. I kind of noticed one thing they've done here that's going to kind of be tricky is what I did on the last one. See how the points aren't in order? Now, you could fix that. You could put the points in order, and it might work out better for you. You don't have to, though, so I'm not going to, just because I want you to see, what they're doing here. Okay, so let's remember, slopes change in y's, which means subtract the y's over the change in x. Okay, so when you're looking at the table, this is what you do. How do I get from -1 to -2? Subtract 1. So for that first set of points, I'll just label them 1 or something. I'll just put a 1. My change in y is -1. What's my change in x over here? How do you get from 0 to 1? Add 1. Okay, so my slope is -1 over 1. Doesn't that reduce to -1? Okay, I'll use a different color for each pair of points. Let's look at the next pair of points. How do I get from -2 to -4? Subtract 2. So on number 2, my change in y is going to be subtract 2. How do I get from 1 to 2 over here? Add 1. Okay, so my change in y is add 1. Ooh, are those two numbers the same when I clean up the fractions? No, I can stop there. I don't have to go any further. These are not on the same line because the slopes are not the same. I mean, I could go do the next pair of numbers, but already it's like I don't have to, because I can already say these are not on the same line because their slopes are not the same. So if you find two that are different, before you do them all, you get to stop. So it's almost kind of nice when they're not the same. Let's do another one of these just to make sure we got this. Okay, so for 33, I'm going to do what they do. I'm going to put it in a table. Plus, we already saw that was kind of a cool way to get the slope just because it was a little less work. There's all kinds of ways to list points, and that's one of the points, if you think about this, that you can put them in tables, you can put them in lists. If you don't like the way something's given to you and you want to rewrite it and it helps you think about it, go for it. It's a good thing. All right, so let's look at the first set of points here. The change in y there, how do you get from 9 to 1? Subtract 8. Okay, so that's going to be a -8 on top. And then the change of x on that one, how do you get from -5 to -1? Yeah, you'd add 4. If you think about the number line, you'd bounce up 4 units, so you'd add 4 to get from -5 to -1. So that's a +4. What is -8 over 4? That reduces, doesn't it? -2 over 1. If I were going to count it off, I would leave it as -2 over 1, but if I'm just going to write it down and compare it with something else, I'll just write -2. When we count stuff off, we actually need a fraction to do rise over run, and so a lot of times I'm going to actually write it as -2 over 1, but this time I'll just say -2. Now let's go to the next set of points. From 1 to -4, how do I get from 1 -4? Subtract 5, right? You could imagine bouncing down on the number line to do it. So this is already not looking great to me because this number is not looking like something that's going to reduce, but we'll go ahead and go through the motions here. This is a -5 is my change in y. How do I get on the other side from -1 to 1? Plus 2. Are those two numbers the same? Yeah, no. So this is also not on the same line. I'm kind of glad they gave you some like this where you had to look at each slope fraction separately, just because a lot of people get the idea that they always sometimes it works out just because they reduce. I have a feeling 31 will probably be good. We'll go ahead and look at it together. Actually, let's not. Let's save the video and do something else here. Okay, so when you get in that 20, those 20 ranges where it's actually asking you to graph, all you're going to do is this. You always go graph the point first. So negative 5, 1, that means x is negative 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and y is 1, so that would be about right here. And again, you want good graph paper. This is hard to do without grid lines, but that's why you want some of that gridded paper. And then, so you start with that, and then use the slope to count to one more point at least. You could do this for as many points as you want to, but you just need 2 at least. You got to have at least 2. So I start here, and the slope is negative 1/2. So what does negative 1 mean on the elevator? I'm going to go down 1. So I'm going to go down 1. That kind of temporarily puts me right where that little dot is, but that's not a point. Don't think that's a point, okay? Because I still am not finished with the slope. Now I have to go run 2, and since it's a positive 2, that means I'm going to go right 2. So I ended up down here, but now I got to count over 1, 2. There's my point. I want to draw my line when I get it. That little dot where I was just counting down 1 is not on the line. That's in the middle of counting off the steepness, isn't it? It's not. A lot of times I've had classes where they think when they count down 1 and I've got that little green dot, they think that's a dot on the line and they try to graph it. That's not on the line. You're in the middle of counting. Don't stop there. Keep counting, okay?